Welcome to lesson number 3, Learn C Programming on the Raspberry Pi. In the first 2 lessons, I introduced you to the Raspberry Pi. Hopefully by now you have one of your own. And I also introduced you to the C programming language. I'm hoping that you purchased a book on C, or maybe just downloaded a free copy somewhere and have started to read it. The important thing is to do a little bit every week, and with some time you'll become a very good C programmer. Anyway, I've already got my Pi here set up and ready to go, so I'm just going to go and SSH to it. Remember that the password is still Raspberry. Okay, so I have now connected onto that little Raspberry Pi, and you can see I have my lessons directory. So let me make a new directory now called lesson03. Oh, spelling mistake. DIR. So today's examples I would put into the directory called lesson03. Okay, so let's go into lesson03, and we have nothing in there now. We'll start up Genie. Once again, I use the ampersand at the end of the command line to indicate that I want this program, Genie, to run in the background. And this will prevent my terminal from being locked out, so I could still continue using the terminal. So we'll start up Genie. And there it is. Remember the last example that we did was we converted inches to centimeters, and we put in I is equal to 12 inches, and we convert to centimeters by multiplying by 2.54, and then we printed out the result. Okay. Today I'm going to show you a little bit more about what these other lines here mean, and a little bit more about compiling from the command line rather than using the build command in Genie. So let's start with another example here. I'll close this off, and I'll start with a new file. And for this example, I'll try to compute, for example, 2 to the power of, let's say, 5. So I'll say this, float result, and I'll say float, let's say x is equal to 2.0, and then what I'll do is I'll print out I'll calculate result first. Result is equal to, let's say, x times x times x times x. Need one more. So that's going to be, the result will be 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So the result should be 32. That's really 2 to the power of 5. In fact, I could put a comment in here. I'll use a double slash in this case for a comment because I want it on the same line. Okay, so I'll say 2 to the power of 5. And then I'll put in a print statement. 2 to the power of 5 is %f/n colon or quote comma space result turn 0. Okay, so here's our program. I'll save it now. I'll save it as in the directory lesson 3. I'll call this, I don't know, we'll call this power.c, or maybe better, let's call it exponent.c. Okay, so if I look inside my directory here, you can see I have the file called exponent.c, and I could now compile it using the GCC command. I could just compile it like that. So here is my source code, and here is my executable. And I've got an error already. Oops, I forgot the closing bracket in the printf statement. So I'll put that in here. Boop. I'll save it again, and then I will recompile, and now it works. So if you look at what I have, is I have the source code is my C program, and in green here, this is my executable code. So I can run it /exponent, and you can see the value of 2 to the power of 5 is 32. Okay, so I want to take a look now at that include statement way up here, and what does it really mean? Well, it basically, what it says is, I want to include a file called stdio.h. So right above the first line here into main, I want to find this file and I want to include it. So I'll replace this entire line here by the contents of this file. So where is this file? Well, let's take a look here. If I go ls/include, you can see that on the Raspberry Pi, it's located in this directory /user/include. So there's the file. There's the file. So by putting this number sign include, what the GCC command does right here is it will take that file and it will include it into the program, and then it will do the compilation. Okay. So what it includes, or what we really need out of that file, is the definition of the printf function. The printf function is part of the standard C library, so we need a definition for it. Okay. So what I'll do is let me go to a web browser here, and I have here a list of all of the functions in the standard C library, and I'll go to the letter P here and look up the printf right here. And you notice for printf, the declaration, the declaration for printf is this. Okay, so I'm going to include that now into my program. So instead of, well, first what I'll do is I'll just take this out. I'll take that out, I'll save it, and then I'll try to recompile using the GCC command. So I do not have the include statement in there, and you see what I have is I've got an error. Basically it's a warning statement, but nevertheless it is an error. It's saying I don't have a declaration for printf. So inside that include that I've deleted, they have that declaration for printf. So what I'll do is I'll just, instead of including the entire file, instead of including the entire stdio.h, pardon me, instead of including the whole thing, I'm just going to include the definition of that printf function. So here we go. I'll just copy it basically from that line on the web page. And they use the word template, but you could use any word you like there, doesn't matter. Let's say X, comma space, and then 3 dots, close the bracket like that. So now I have, instead of having the number sign include stdio.h, I've just put in the definition of the printf function, because that's all I'm using. If you look in my main, the only function I'm using is printf, and that function belongs to the standard C library, and that's basically what we call the prototype, or I guess you could call it the function definition. Okay, so I'll save this guy like this, and now I'll try to compile it, and you notice it compiles successfully, and in fact I can run it and it gives me the same answer. Okay, so that's one thing to remember, is that whenever you use number sign include H, what you're doing is you're including a bunch of definitions, among other things, but basically a bunch of definitions. In this case we're only using printf, so we only need the definition for printf. But Most programmers don't do that. They always just include the entire file. If you look at the file again, let's just take a look at it. Cat, well, not cat, let's say wc-l/usr/ include stdio.h. I just look at it. It says it has 947 lines in this file. So you see, my program here is only, I mean, if you look at it from 3 to 9, 1, 2, 3, 4, 5, 6, 7 lines of code, but this file adds an extra 947 lines. This little command I'm using in Linux is word count. Word count with -l option says I want to list the number of lines in this particular file, count the number of lines in this file. So I have 947 lines. So that's what the include does, is it includes 947 lines. One of those lines is basically the definition of printf. Okay? Okay, the other thing I want to show you is that there's a file oops, it's not in user lib. Well, I guess I should have looked for the C library earlier before I started this, so I apologize for that. But anyway, there is a file somewhere on the system called libc.so, and this is the library that actually holds the printf function. Remember that the file stdio.h only contains definitions of things. It does not contain actual code. The C library, libc, contains the actual code for the printf function. So when I compile exponent.c -o exponent C, I could add on this extra option here, library. -l means library, and C says please include the C library. So you notice it compiles perfectly, because the reason is because the C library is included by default. So you never have to put -lc. Okay? So let's do another example here. I'll change this to, instead of doing it this way, I will use another built-in function, and I'll say result is equal to let's say POWF, power function of x comma y, but now I got to declare y, float y equals 3.0, or let's 5.0. Okay. So instead of multiplying 2 by itself 5 times, what I want to do is I want to call a function called power f, which is the f is for float, which means x and y are two floating point numbers. So x to the power of 5, and the answer should be 32 as computed by this power function. Okay? And then when I get the answer, I print it out using the printf. So let's see what happens when we try to compile this guy. Once again, I could include the C library, but I don't have to because it's included by default, so I'll just leave it like that. And now look what I get. I get an error here saying, well, I don't know what the heck this POWF function is, so you better define it. Well, the POWF function is defined in math.h. So if I go number sign include math.h, now I have the definition of the POW function. So I'll save it, and let's see what happens now. This time you notice it seems to compile correctly because it knows the definition, but it cannot find the power or POWF function. That's because the POWF function is in another library called the math library, and the name of the file is just lib, L-I-B-M. So I would have to compile using the math library, so -LM. And now you see it compiles correctly, and I can actually run it, and I get 2 to the power of 5 is 32. Okay. So if I wanted to, I could also, for the printf function, -LC, I could have also included the C library. But as I said before, and I guess I'm repeating myself, the C library is included by default. So for this example here, I have two functions I'm using. I'm using the POWF function, which is described in this file, and I'm using the printf function, which is described in this file. Now, the printf function is contained in libc, and the power or POWF function is contained in libm. Okay, so that's why up here I put in the math library and the C library. Okay, so I hope that doesn't confuse people too much, but let's go back and look at now on the web page here. These are all the functions that are available within the standard C library, and you'll notice there are thousands. For example, some of the functions you'll see, this is the A tan function. If you're familiar with some trigonometry, there's the A-sine function. These are the arcsine, arctan functions. Let's go down here and look for some other things. Well, I think we should find one function. Let's go take a look in under the S's, and we should find a square root function somewhere. SQ, where is it? Oops. Here it is. Square root float. Okay. So square root float, you give it a floating point number and it gives you back the square root. Well, let's try that. Let me just put that over here. So what I'll do is I'll say the value of 2 to the power of 5 is 32, and then we'll say, I'll change the value of result again to, well, I'll call it, no, it's okay. Result is equal to SQRT F of result. And then I will printf the value of, or not the value, let's say the square root of result percent %f is percent %f slash n comma result comma result 1. I guess I'll need another variable here. So I'll go up here and float result. I'll just add another result 1 and result 1 down here. So if you look what I'm doing, I'll save this guy. I have two results. Result, which is the 2 to the power of 5, and then result 1 will be the square root of 32. Okay, so now you notice I'm using three functions. I'm using POWF, which is the floating point power function. I'm using square root f, which is square root function, and I'm using printf twice here and here. Okay, so again, printf is part of libc, and POW and SQRT, I think SQRT is part of libm, or the math library. So let's compile it and see what we get. And you can see the value of 2 to the power of 5 is 32. The square root of 32 is 5.656854. Okay. All right. I think we have done enough for this lesson. Again, let's just rehash what we learned. We learned that these include statements are used to include files that exist on the system, include them into our program. And we also learned that these files just contain definitions of various things, definitions of functions. We also learned that the C library contains, up here, thousands of functions, and they're available just so long as you make sure you put in the proper header file to use them. On the command line, we learned that when we compile, we do not have to include the C library because it's included by default. But any other libraries we will have to include them using the -L option. Okay, so you see it still compiles and it still runs correctly. Okay, thank you very much. Keep reading your book. practice some of these examples and keep programming on the Pi. And we'll see you next week.